Today, it seems like nobody spared the wrath of the spectrum-hungry monster known as 5G. The telecom companies, in their quest for even more spectrum, which has sometimes been likened to a huge land grab, has really spared nobody in its path. Except when you're faced with the prospect of planes falling out of the sky and crashing into things. This is where they have to take things very seriously. I'm Rhea, and welcome to Rhea's Shack. Today we explore how pilots are concerned about 5G being a threat to aviation safety. But first, if you do like the content, why not give us a thumbs up and hit the subscribe button? You're already awesome for watching this video, and doing this makes you even more awesome. Thank you. So in the air, you generally need to know a few things to fly safely. One of them is how high you are in absolute terms, meaning height above sea level, and another is where nearby objects are in relation to you, so you can avoid colliding with them. In the cockpit, you have instruments called altimeters, which give you a readout of your altitude or how high you are. There are 4 general types. One of them is the barometric altimeter, which depends on barometric or air pressure, which varies with altitude, since air pressure is lower the higher you go. And another uses GPS or other satellite-based systems. Another type uses lasers, and the last type uses radio waves and is a form of radar. This is the radar altimeter. The radar altimeter is important to commercial aircraft because it allows a pilot to accurately measure altitude above ground so they can begin the flare maneuver or round out, which is after final approach, and where the pilot raises the nose to slow the descent rate prior to touchdown. During low visibility conditions, it is especially important as a pilot will be flying under instrument flight rules, where the pilot depends mostly or almost entirely on instruments to fly and land the aircraft. In the military, it allows aircraft to fly low to the ground, avoid objects, avoid detection by anti-aircraft guns or surface-to-air missiles. So what does 5G have to do with this? One of the frequency ranges recently allocated to 5G is in the C-band, which is 3.7 to 3.98 gigahertz. Yes, I know C-band is typically known as 4 to 8 gigahertz, but this is what is called a C-band for 5G. Incidentally, you may have seen a C-band receiver without even realizing it. The big dishes that people used to use to receive satellite TV also operate in the C-band. The wireless industry paid $78 billion US dollars to the FCC in a spectrum auction to obtain licenses to operate in this frequency range. This frequency has become very desirable to the wireless carriers due to the ability of them to have 50 megahertz channels to push lots of data over long distances. It's a sort of the holy grail because you not only get fast data speeds due to wider bandwidths, but the frequencies are low enough that you can propagate further than higher frequencies, which right now are better suited for more urban areas. Radar altimeters typically operate in the 4.2 to 4.4 gigahertz bands, which is quite close to that previously mentioned 5G frequency range. 5G cell sites will be transmitting hundreds of watts of power, thousands in the aggregate, and there is a concern that this will cause interference with radar altimeters. Testing has shown anything from inaccuracy to outright failure of the instruments. So you may ask, what has been done? Well, the wireless carriers were supposed to start deploying 5G in the 3.8 gigahertz frequency spectrum in early December 2021, but have now delayed by an additional month in order to study the safety effects. This was in response to the FAA putting out a bulletin advising radar altimeter manufacturers and aircraft manufacturers to provide technical data about susceptibility to interference and advising pilots to take precautions and prepare for degradation of their altimeter readings due to 5G. This includes ensuring passengers turn off their cell phones during flight, which by the way they already do, or are supposed to do. But I do have to ask, what will this delay do? And will it really solve the problem of these altimeters giving inaccurate readings or simply failing to operate? We rely heavily on aviation for everything from visiting grandma to fighting wildfires, and for that latter case, the experts are saying that it would greatly affect those operations. There are no easy answers to this, and I hope that in the end we come to a workable solution that doesn't result in planes falling from the sky or crashing into things. What do you think? Sound off below. I am Ria, and to RJ, keep on having. See ya.